L square is equal to x minus x2 whole square plus under root of 1 minus x1 square minus 4 upon x2 whole square, where x1 belongs to 0 to 1 and x2 belongs to all real except 0. We want to evaluate the minimum value of this L square. First of all, I would like to assume this 1 minus x square here as a function. So let y1 is a function and it is written as 1 minus x1 square with the under root. Now squaring on both sides, we get y1 square is equal to 1 minus x1 square, and on further solving it becomes x1 square plus y1 square equal to 1. Since we know that x square plus y square is equal to r square is the equation of the circle with center 0, 0. So comparing these two equations, we get a circle with radius 1 and center as 0, 0. In the next step, treat this 4 upon x2 as separate function. So I'll assume y2 is equal to 4 upon x2. Since we have x1 and x2, so we can consider that x1 is the input for the first function and x2 is the input for the second function. If we focus on this function, we can imagine at least that this is a function kind of this, because here as we can see x2 cannot be equal to 0 because 4 upon 0 will be the undefined state, so it will be kind of rectangular hyperbola. Here as x2 tends to 0, y2 will tend towards infinity, and as x2 tends to infinity, y2 will tend towards 0. So after forming these two equations, I can see that first equation represents the circle here with the radius r and having a point x1 and y1 on the circle, and second equation forms this kind of graph which is kind of rectangular hyperbola with x2 and y2 as input and output. As x1 belongs to 0 to 1 and we assume y1 as under root of 1 minus x square, so we will only work on the first quadrant from 0 to 1. Although we have a circle, but this is 0 and this is 1. From 0 to 1, these are the inputs and the curve will form from here to here. So 0 to 1 and the curve is in under root, so the under root should be positive, so only we will consider this curve from here to here. L is the distance between the point A and B, because according to distance formula d will be under root of x1 minus x2 whole square plus y1 minus y2 whole square. So x1 minus x2 whole square will become kind of this, and y1 and y2 on putting the value can become like this. So L is the distance between the point A and B. L is equal to distance between both the curves. Identify the fact that minimum distance lies along the common normal. If this is the tangent from this point, let's say, so the common normal will be this. So this will be, this distance from here to here will be the minimum distance. So we need to find this value of L. Let us assume the coordinates of point B is t comma 4 upon t, because y2 is equal to 4 upon x2. So for t, the value of y will become 4 upon t. And we know that the slope of the normal multiply the slope of the tangent is always equal to -1. This point here is O. So slope of normal is equal to slope of OB, where O is the origin. So slope of OB can be written as 4 upon t minus 0 upon t minus 0. Change in y upon change in x. MOB is equal to 4 upon t square. Now for slope of tangent, at point t comma 4 by t, this will become minus 4 upon t square, because y2 is 4 upon t and derivative of 4 upon t is minus 4 upon t square. We get 4 upon t square minus into 4 upon t square equal to -1. So from here t to the power 4 is equal to 16. So t becomes 2. So which implies 4 upon t will also become 2. Therefore B is 2 comma 2. Now we would like to find the value of L. L is nothing but OB minus OA. OB is the distance from the origin to point B and O is the distance from origin to point A. So OB minus OA will give us this length, which is the L. OA is the radius, so L can be written as OB minus R. Now we can find the value of OB because we know what point B is. So OB is under root of 2 minus 0 square plus 2 minus 0 square with the under root. So OB is 4 plus 4 with the under root, which becomes 2 root 2. And OA is your radius, which is equal to 1 from x1 square y1 square equal to 1. This 1 represents here the radius, so radius is equal to 1. Therefore L becomes 2 root 2 minus 1. But we want to find the value of L square, so it becomes 2 root 2 minus 1 whole square. So L square is 9 minus 4 root 2, which is the required answer.